This is the Law of Sines and Cosines tutorial. Let's begin the lesson by discussing the law of sines. The formula for the law of sines is the sine of angle A over side length A is equal to the sine of angle B over side length B is equal to the sine of angle C over side length C. You can see on the triangle to our right, we just have triangle ABC and we've shown the side lengths there. Side length C is directly across angle C, and side length A is directly across angle A. What's important about the law of sines is that you can use that information to solve for any missing angle or side length of a triangle, given that you have some of the information of that triangle. So let me show you an example problem of that. In this problem, I've given you the angles of A, B, and C, and the side length of C and the side length of B. However, you're missing the side length of A. We can use the law of sines to solve for that missing side length. What we would do is take the sine of angle A, which is 40 degrees, over the side length A, and set that equal to the sine of angle B, which is 88 degrees, over the side length of B, which has a length of 14. Now I'll rewrite this proportion, and I'll plug in the actual values of the sine of 40 and the sine of 88. The sine of 40 has a value of 0.64. And we'll write that over side length A. That's equal to the sine of 88 degrees, which has a value of 0.999, over the side length of B, which is 14. Now, we're going to cross multiply these two proportions. So we have 0.64 times 14, which has a value of 8.96. And that's going to be equal to A times 0.999. So we have 0.999 A. Well, we want to solve for A, so I'm going to divide by 0.999 on both sides of the equation. And we'll get A is equal to 8.97. Now we were able to solve for A because of the law of sines. Now let's go ahead and take a look at the law of cosines. Alright, so the law of cosines is actually broken up into three distinct formulas. In each one, you could either solve for, like for example in the top formula, angle A or side length A. You'd use the second formula to solve for either side length B or angle B. And you'd use the third formula to solve for either side length C or angle C. So let's go through a practice problem and I'll teach you how to solve for, in this case, angle A. Imagine you were given a triangle with three side lengths, and you were asked to solve for the different angles of that triangle. What you could do is use the law of cosines to solve for those different angles. So let's use these different side lengths to solve for angle A, and we'll use that top formula there. So what we have here is A squared, the length of A squared, and if you recall, 6 here, because it's directly across from angle A, is the side length A. So we have A squared, or 6 squared, is equal to side length B squared, so 9 squared, plus side length C squared, which is 8 squared, minus 2 times side length B, which is 9, times side length C, which is 8, times the cosine of angle A. Now we want to reduce these things. We want to simplify. So 6 squared is 36, is equal to 9 squared, 81, plus 8 squared, 64, minus 2 times 9 times 8, which is 144, times the cosine of angle A. So we'll go ahead and add 81 and 64 on the right-hand side of our equation. And we have 145. Carry down that minus 144 times the cosine of angle A. Now I'll subtract 145 from both sides of our equation. So we have negative 109 is equal to negative 144 times the cosine of angle A. We want to solve for angle A, so I want to divide off this negative 144 on both sides of the equation. So what we have on the left is 0.76 is equal to the cosine of A. So to solve for A, we'll take the inverse cosine of both sides, and we'll have the inverse cosine of 0.76 is equal to angle A. So angle A has a value of 40.54 degrees. Now you can use these other two formulas in the law of cosines to solve for angle B and angle C if you'd like. It's going to be the same exact setup. You're just going to plug in the side lengths that you know and then solve for that angle that's missing.